So real quick, let's just look at some important things to remember when we're making a stem plot. The most important thing, probably the thing that you're going to forget the most, is you must have a key. Must have a key. So make sure you always have a key. It includes units. Make sure you have a key that includes units. Now, I'm going to draw a bad stem plot-ish, mostly bad. I'm going to draw kind of a bad stem plot to make a point, but here it is. 1, 2, 3, 4. Let's see. I don't know. 3, 4, 7, 9, 2, 8, 3, 1, 2, 1, 5. Okay, cool. Let's make some points here. First of all, what's wrong with this stem plot? Right? The spacing, right? So just like a dot plot and how it's important to line up your dots in a dot plot, it's important to line up these leaves in a stem and leaf plot or stem plot so that you can accurately see the shape and you can see the peaks and things like that. So carefully space leaves. So that's going to be important to do. Another thing that's wrong with it. What's another thing you see that's wrong with it? Yeah, the numbers aren't in order, right? So make sure your leaves are in order, okay? Leaves must be in order. Okay, cool. All right, and then one thing that was done correctly here. So notice that there's none in the 3, or with the 3 stem. So there's no 30s in this data set. If you don't have something in the category, you do still need to show it in order, right? So my stems are 1, 2, 3, 4. My numbers go from 13 to 45. I do need to have a stem there to show that there are no 30s. So don't skip any stems, even if there's nothing in that particular category. So do not skip stems. Okay. Any questions about stem plots? Yay! So we've talked about 2 different kind of quantitative graphs. We've talked about dot plots and we've talked about stem plots. Now we're going to talk about histograms. You guys know what a histogram is, right? So what does a histogram look like? Kind of looks like a bar chart, but the bars touch, okay? So the reason for that is because it's quantitative and each of the categories goes right up into the next one because it's values, it's numbers. Where on a bar chart, each category is just separate. There's not really like an order or a flow to the next one, usually. So this is a table that represents the number of free throws made for the Sweet 16 NCAA teams from 2019. And we're going to make a histogram. So the first thing you need to do whenever you're making a histogram is figure out what your scale is going to be. So what is the lowest number in this data set? Good, 406, very good. What is the maximum number in this data set? 635, very good. So that kind of gives me an idea that I need to get from about 400 up to about 635. Now I need to think about how wide are each of these categories or bars going to be. If I were to go by, like, for example, tens, right? 400 to 410, 420, 430, then I'm going to have a lot of bars. I would have like 25 different bars. That's a little much. That's a little too detailed. Each bar would be pretty short or have nothing in it. So that doesn't seem like a good idea. So what spacing do you think would be a good idea? How much should we go by? What do you think? Any ideas? What do you think? 5s, 10s, 15s, 20s, 25s, 30s? What do you want to go by? You want to go by 20s? 10s? 20s? Yeah, so 20s, if we go by 20, then we would have like 10 different bars. We're getting close-ish. Usually for a histogram, you don't want any more than 10 categories. You want somewhere between 5 and 10 different categories. So what are we thinking? So maybe we need to go a little higher than 20. 25s? Let's go by 25s. I like it. So we're going to have these categories, 400 to 424, 425 to 449, 450 to 474, 475 to 499, 500 to 524, 525 to 549, 550 to 574. This is like the annoying part of statistics is making graphs. 600 to 624, and then 625 to 649. Okay, cool. So these are going to be our groups. Whee! And now for the real fun. You got to figure out how many are there in each of those groups. So, there's a couple ways you can do this. Kind of the most efficient way, instead of like searching all of the numbers every single time, kind of the most efficient way would be like to make tally marks, right? So like 450, and that would go, oh dang, 450, that would go there, and then 579, that would go there. Okay, so anyway, so you guys figure it out, go.
What is that, a 6? Is this supposed to be 6? 649? Well, I didn't know that. I'm like, wait, what am I using? Or talent? Talent. I said that. Okay, so you see this, your talent. So 450 would go here. Okay. Stop making at me. Okay. Sorry. Really? Shut up. Oh wait, that's a check mark. Yeah, that's what you get. 508. I don't even know what's going on. Is it football or basketball? I don't know. Good for you. Thank you for telling us.
All right. Do you got them? No, not yet. Okay. All right. Here it is. What's the first one? 1, and then? 3? Okay, and then? What's the last one?
The last one Yeah, the first two.
All right, let's start back at no. 3.
It's 3. Then it's 2. 1.
1.
Then it's 2.
2. And then 1. Okay. All right, cool. So there we go. There's that. Here we go. Let's make our histogram. Whee! Oh, that was terrible. Okay. Whee! All right, 400, 450, 475, 500, 550, or 525, 550, 575, 600, 625, 650. Okay, cool. 1, 2, 3. 1, 2, 3. Yeah. I sure did. Because I missed 425. All right, all good. All good.
That doesn't make sense. Yes, it does.
All right, so basically it's as easy as you just make the bars. Oops.
Looking at my graph, can you stop looking at my graph? You really did. Stop looking at my graph so I look over and look at I'm a little lost. Me too. That's what you do. Oh, I can start with it.
So there it is. The only thing is we just need to make sure that we label our axis. So on the x-axis here, what are those numbers indicate on the x-axis?
16 NCAA. Oh, the number of free throws.
Yeah. All right, and then what is my y-axis?
How many teams?
Yes, number of teams. Good.
Wait.
All right, and then it says to describe the distribution. What does that mean when I ask you to describe the distribution? Use socks. And what does socks stand for? Shape, outlier, center spread. Shape, outlier, center spread. Shape, outlier, center spread. All right, so let's talk about the shape of this. What do you guys think this shape is? Yeah, this is for sure bimodal. Bimodal. Yeah, it's probably skewed left with that one anomaly of this one category here. So yeah, I mean, probably like a little slightly left skew. Left skew. All right, outliers. You guys think there's any outliers? Nah, there's none. All right, center. Let's talk about center. I am supposed to cover for James Martin in the front tomorrow morning, period. Do you want me to do that or help on the south end? Question mark.
My bad,
And just to be clear, comma, you are wanting me to start helping on the south end every morning for this quarter? Question mark. That's fine. Okay. Sorry, guys. My boss was texting me, and so I had to respond to my boss. Okay. Center. Let's talk about center for a second. How many total are there? Did somebody just ask me to go to the restroom? You can go. Oh, I didn't know I was like, what are you doing? You're filling out the pass. Okay, cool. Look at you being a great student. All right, so how many total are there? Sorry. 16. There's 16 of them. Very good, very good, very good. So where would be the middle one? Where would be the middle person? The 8th value, right? So watch this. Have I gotten to the 8th value yet? Am I at the 8th value yet? No, I'm at 2. Where am I at now? I'm at 5. Am I at the 8th value yet? I'm at 6, 7, 8. Here's where the 8th value occurs. So what's the center? It's in here. It's in this one because that's where the 8th value occurs, which is the middle of the distribution. So that is from 525 to 550. Let's pretend we don't have any of that information and all you guys have is this histogram. That's all you got, okay? What is the median of this histogram? Well, we just found where it's at. It's in the 525 to 550 mark here. So do I say 525 or 33.5? No, I don't say that. The median is this group right here. If I don't have this chart, if I just have the histogram here, then I don't know what the numbers are inside of each of these groups specifically. I don't know what the numbers are. I just know it's somewhere between 525 and 550. So you never want to give a number that's exact on a histogram unless you know the exact numbers. All right, so my center here would be 525 to 550. And I'm going to say that that's the median. I forgot to say that. The median is somewhere between 525 to 550. If I didn't know all the individual data, then I wouldn't be able to tell it specifically. All right, the spread. What's the spread of this data? Good. Because you guys did have the data, yes, the spread is up there at 406. to 635. So that would be our spread. That would be our spread. Man, I ran out of room here. Now, just question real quick. What if we didn't know the individual data? What would the spread be? 400 to 650, because I wouldn't know any of the details of what's inside there. Does that make sense? Awesome. What does SOC stand for? Beautiful, beautiful, beautiful. All right, histograms. Use them wisely. Don't confuse histograms with bar graphs. Histograms are quantitative. I wasn't done writing. Quantitative. And the bars touch. Bar graphs. Bar graphs are categorical. The bars are separate. Quantitative versus categorical.
Short.
All right, now, this is just a little side note here, okay? I'm going to draw you guys a categorical graph here. Red, orange, yellow, green, blue, and red, orange, yellow, green, blue. Okay, cool. So here's a categorical bar graph. Are you with me? Perfect. What is the shape of this distribution? Perfect. Kyle said it. There isn't one. Like, we should never use socks on a bar graph. You know why? Because I can reorganize this any way I want. I could put blue first if I wanted to. I could put them in alphabetical order. I could put them in order from highest to lowest. I can change the order of a categorical variable, okay? So we never use socks. Also, like for center, what would I be like? The center is yellow. The spread is red to blue. Like, that's just silly. So never use socks on a categorical variable. Okay? All right. Next, we are going to want to use percents or proportions instead of frequencies on the vertical axis when comparing distributions with different number of observations. We talked about this already. We're going to use relative frequencies when we have data that has different numbers, different totals. So this is like think about like a medical journal, and this is like an airline magazine, and we're counting the word length from them. Well, obviously, this journal has more 3-letter words than the magazine has, right? And it looks like it's a significant amount. Well, but why? A journal just has more words, period, than a magazine. So this is the frequency, but when I put it on a percentage basis, they look very similar. They look like they have very similar type word lengths. So again, just be careful about using counts if you're comparing two different distributions. And then the final little note here is just because a graph might look cute doesn't mean it's helping you do anything, right? You want to use graphs to summarize data. Graphs are used for summarizing data. This graph on the left, this is like students and their name length. So student number 1 has a seven-letter name. Student number 2 has a 4-letter name. Student number 3 has a 4-letter name. I could just tell that by looking at their names on a piece of paper, right? I don't need a graph for that. But if I'm trying to summarize something like what is the most common name length, then now this summarizes something, and it's a useful graph and it helps me. So don't make a graph just to make a graph. Make sure it's useful. Any questions about that? All right, I have one more question for you. Actually, I have 2 more questions for you, but here's the first one. Imagine asking a random sample of 60 students from McKinney Boyd High School about their birth month. What should you use, a bar graph or a histogram? Bar graph. Why? Very good. You should use a bar graph because it is categorical data. Yay! Any questions, comments, or concerns?
Amen.
1.2 is in the books.